Hello and Assalamu alaikum guys. In this particular video, we're going to be talking about the quantitative analysis of speed time graphs. So as we already know that the gradient of the speed time graph represents acceleration. So if it is a straight line segment, then we can find out the acceleration by calculating the gradient of that particular line segment. So if I look at this particular segment, which is from 0 to 4 seconds, and I need to find out its acceleration, then I'll read the two coordinates, 0 and 0. The other one is 4 and 15. And then I can find out the gradient by using the formula y2 minus y1, in this case, v2 minus v1, over x2 minus x1, in this case, t2 minus t1. So that gets me the acceleration for this particular section. Similarly, I can take any particular section of line over here and find out its acceleration. Over here, you can see it's a flat horizontal line. That means the acceleration must be 0 for this time interval. And if the graph is coming down, I know it must be decelerating. So when I calculate the gradient will come out to be negative, which means it is decelerating, and I can calculate the deceleration. Since distance traveled is the product of speed and time, so for non-uniform speeds, the distance is calculated by area under the speed time graph. So if you have a speed time graph and you calculate the area for any particular section of the graph, that will calculate for you the distance traveled during that time interval. So if I look at this particular area, it's forming a triangle shape. So I'd find out the area by using half into base into height. And once I calculate this area, I know that the object travels a distance of 30 meters in the first 4 seconds. Similarly, I can break different areas into different shapes. This A2 is a trapezium, so I apply the formula half sum of parallel sides into height. And once I get that area, that tells me the distance traveled from 4 seconds to 10 seconds. If I want to find out the distance traveled from 10 seconds to 20 seconds, so I'm going to calculate the area of this rectangle. That will get me the area that would be length into breadth. Finally, for the last phase of the journey, when it is decelerating, that's forming another triangle, so I can calculate the distance traveled by area as half into base into height. So that's how I can calculate distances and accelerations using speed time graphs. I can also calculate the average speed, because if I've calculated individual distances, I can add them up to get the total distance traveled. And once I divide total distance by total time, I'll get the average speed for that part of the journey. Let's look at some other examples. And this is another speed time graph. If I have to find out the distance, that will be the area of a triangle. That'll be half into 5 into 20. And if I want to find the average speed, so I'll do total distance, that is coming out to be 50 by time, that is 5, and I'll get the average speed for the journey, which is coming out to be 10 meters per second. And in case if I want to find out the acceleration, so I'm going to calculate the slope of this particular line segment. This coordinate is 0 and 0, and the other coordinate is 5 and 20. So I do 20 minus 0 over 5 minus 0 to calculate the gradient, which comes out to be as an acceleration. Similarly, for this particular graph, to calculate the distance for the first part of the journey, I'll calculate the area of triangle whose base is 4, height is 12, half base into height gets me the distance traveled for the first phase of the journey. And if I have to calculate the distance traveled for the second phase of the journey, that would be 1. This is basically forming a rectangle, so that'll be 1 times 12. I know this graph is a little out of proportion, but somehow this into this will get me the distance traveled for the second part of the journey. And then I can add them up, and I'll get myself the total distance traveled. Average speed will be total distance upon total time. For first part of the journey, I'll calculate the gradient to get the acceleration. That would be 12 upon 4. For second part of the journey, I know acceleration is 0. Similarly, as I move on, I can also calculate the total distance traveled in one go by identifying this as a trapezium which would be half sum of parallel sides. One side is 7, the other side is 5 minus 3, that is 2, and the height of the trapezium, that is 8. Or I can break this up into 3 different shapes: triangle, rectangle, triangle, and add these areas up, and that will also get me the total distance traveled. Similarly, I can find the average speed, dividing it by total time, or I can also calculate the accelerations for any particular section. Let's see how this is asked in exam. Like if you look at this MCQ, it says the graph shows the movement of a car over a period of 50 seconds. What is the distance traveled by the car during the time when it was moving at a steady speed? Now, this is a good example of a question to make me realize that how important it is to read a question. I am not being asked to calculate the total distance traveled. I'm only asked to calculate the distance traveled when the speed was steady. That is from 20 seconds to 40 seconds. That would be this particular area whose width is 40 minus 20, 20, and height is 10. So that'll be 20 times 10, and I'll get myself the answer as 200 meters. Moving on, then this another question says the graph shows the movement of a car over a period of 50 seconds. What was the distance traveled by the car when speed was increasing? So again, I do not have to calculate the total area. I just have to calculate the distance traveled when the speed was increasing, which should be the area of this particular triangle. So half, base is 20, height is 10, and that gives me my answer as 100 meters. Let's have a look at some of the structured questions. It says, the graph shows a speed time graph for the first 125 seconds of the journey of a lorry. So I can see that this is the graph where the speed is increasing at a constant rate, then speed is increasing at a decreasing rate. So here the acceleration must be constant, here the acceleration must be decreasing, and finally the acceleration becomes 0 because it's a horizontal graph. It says during the motion, describe what happens to the speed of the lorry. So there are 3 phases. In the first phase, the speed increases at constant rate. I can sort of identify that happens till this point of time. So that should be till 25 seconds. Then I can say that afterwards, the speed increases at a decreasing rate. So that's going to happen till 55 seconds. So then speed increases at decreasing rate. And that happens from 25 seconds till 55 seconds. And then what happens to the speed? From 55 seconds onwards, then speed becomes constant. For the next question, it says, what happens to the acceleration? Since the speed increases at a constant rate, so till 25 seconds, acceleration is constant. And then acceleration decreases till 55 seconds. Then finally, acceleration becomes 0. As the gradient is 0. Moving on, it says, determine the maximum speed of the lorry in meters per second. So I have to find out the maximum speed in meters per second. So I would look at this graph and I'd identify that's right between 20 and 30. So that should be 25 meters per second. So the maximum speed of the lorry is 25 meters per second. You should also know that 1 kilometer per hour is equal to 1000 over 3600 meters per second. So 1 meters per second must be the opposite of that. That's 3600 by 1000 kilometer per hour. The 1000 over here is for kilo and 3600 is for the number of seconds in 1 hour. So it's an important ratio and you should remember this. So if I have speed in meters per second and I have to convert that into kilometers per hour, so I'm going to do 25 times 3600 divided by 1000. Looking at the next question, it says figure shows a simplified speed time graph for a train that travels between two stations. Describe the motion of the train. So we can see initially it is at rest till 20 minutes and then it starts traveling with a constant speed of 20 meters per second till 65 minutes and then it again comes to rest. So that is something I can describe about the motion of the train. Stays at rest till 20 minutes, moves with constant speed from 20 minutes to 65 minutes. And then comes to rest again. Then it says calculate the distance traveled by the train between the two stations. Since it is a speed time graph, so the distance traveled by the train must be area under the speed time graph. So I'm going to calculate this area of a rectangle whose height is 20 and whose width is 65 minus 20. That should be 45. But don't forget that speed is in meters per second, and whereas time is in minutes, so I'm going to have to multiply this by 60 to get myself the time in seconds as well. As I calculate this time, this comes out to be 54,000 meters. So I can write it as 54,000 meters, or I can also write it down as 54 kilometers. In the next part of the question, it says another train travels between the same two stations on a particular track. This train travels at a constant speed. It starts its journey at 0 and finishes at 90. Draw the speed time graph for this train. So, I mean, there are various ways to look at it, but you know that it's traveling at a constant speed. So, the distance must be equal to speed into time. And for the same distance, speed and time are inversely proportional. So previously it was traveling in 45 minutes and now it is traveling in 90 minutes. So the time is doubled, the speed must be halved. So I can easily figure out that it must be traveling with half the speed for 90 minutes to travel the same distance. In the next question, it says figure represents the motion of a car along a straight road. As the car approaches a small town, it slows down. So we can see that the car actually slows down and it travels with a slower speed and then speeds up again when it reaches the end of the town. Determine the speed of the train in the town. So I'd have to read the value of speed from the y-axis. If you look at the y-axis, it's basically 10 units with 10 boxes. So each box must be equal to 1 meters per second. And I can find out the speed as 12 meters per second. That is something I can directly read. Please note, if there's a question where for the answer space, the unit is not given, then it is your part of the job to write down the unit. Determine the time taken by the car to pass through the town. So I read the two time values and I'm going to subtract those to get the time taken to pass through the town. There I also have to keep in mind that there are 20 boxes for 10 seconds. So each box must be equal to 0.5 seconds. So if I would read this time, this should be 11 and 12. So initial time is coming out to be 12 seconds. And if I try and read the final time, this is 25, 26, 27, and 28. So the final time is 28 seconds. Time for which it is in the town would be the difference of these two times. So I do 28 minus 12 and I get my answer as 16 seconds. Calculate the distance traveled by the car in the town. As we already know that distance traveled is the area under the speed time graph, so if I find out the area of this rectangle, I'd be able to calculate the distance traveled. So that's going to be 12 times 16. So this area is coming out to be 192 meters. So this should be 192 meters, and I'm also supposed to write a unit of time here, which is seconds. The car accelerates after passing through the town. Get the acceleration and also get the unit to your answer. So when it accelerates, this part of the graph actually represents the acceleration. It is a straight line segment. The gradient of this line segment must be equal to the acceleration. So I can read the initial point and I can read the final point and determine the gradient. This point is 28 and 12. If I read the other point, that's basically 31, 32, 33, and 34. So the final time is 34, and the speed at the final time is 28. So to determine the acceleration, I'm going to find out the slope or gradient of this line segment. y2 minus y1 must be 28 minus 12. And x2 minus x1 must be 34 minus 28. So this is coming out to be 2.67. Not to forget that the acceleration is given in meters per second square. So that's how I solve this last part of the question. In the next question, it says the window cleaner drops a sponge from the balcony of a hotel at time t is equal to 0. Figure 1.1 is a speed time graph for the motion of the sponge. State a value of t when the sponge is moving with a constant speed or a uniform speed. So we can see that for this part of the journey, the speed is uniform or constant. When I have to state a value of time, I can state any value of time from this 1.6 seconds to 2.5 seconds. So I can mention anything in between that, and quite randomly, I choose 2.0 seconds. And then it says accelerating at a non-uniform rate. This straight line segment is telling me that the acceleration is uniform or constant here, whereas this curved section is telling me that the acceleration is decreasing. So over here, the acceleration is decreasing. Anything that I write between 1 and 1.5 should be an acceptable answer for non-uniform rate. So that means the answer can be written down as 1.2 seconds. I also have to tell the time when it is decelerating. Decelerating is when speed is decreasing. There's a very sharp decline in speed only at 2.5 seconds. So if I have to tell the time when it is decelerating, I'm just going to write down, there's only one possible option that I can write down, and that is 2.5 seconds. It also says calculate the distance traveled by the sponge between 0 and 0.75 seconds. So if I have to find out the distance traveled from 0 and 0.75 seconds, that should be area under the graph. So I'm going to carefully read 0.75 on the x-axis and its corresponding y value on the y-axis. So if 2 is represented by 5 boxes, each box must be equal to 0.4. 6.4, 6.8, 7.2, and 7.4. So the y value or the speed value that I get over here is approximately 7.4. So the area under the graph, which should represent the distance traveled, must be an area of triangle, which would be half times 0.75 times 7.4. And this gets me the distance traveled. And the distance comes out to be 2.8 meters. Thank you so much, guys. So if you really liked my video, please click on the like button and also subscribe to my channel for more informative videos.